Hello everyone, welcome to our online open course. We will learn the second process of program design for flat and straight-walled products. This process is the rough machining of the outer contour. In this process, we use the method of flat contour milling, which is similar to flat milling. It only requires creating a 2D wireframe instead of the 3D modeling design for programming. This process is typically used for rough machining of outer contours. However, in its application during rough machining, it's crucial to pay attention to the selection of boundary lines, as incorrect choices will prevent the generation of rough machining paths. Therefore, when rough machining, do not select the boundary lines of the bottom surface as the contour boundaries. The operational breakdown steps are as follows. First, enter the UG machining interface and open the part machining option to create the process using the flat contour machining method. 1. Specify the cutting area. 2. Setting the tool path. Second, generate tool paths and simulate them. For detailed operational instructions, please refer to the skill operations. Let's start the external contour rough machining process. Click on Geometry. Right-click to find Insert, then find Operation, and choose Planar Profile Milling. Select the 30 mm diameter tool and the AA geometry. Choose Rough Machining and enter External Contour Rough Machining Process as the operation name. Then click OK. Select Boundary. Pick the external contour boundary. Choose Curve Boundary and pick the specific curve. The tool side is set to the outside. Then click OK. Pick Specify Bottom Surface and choose the indicated bottom surface. Then click OK. Set the common variable step over to 1 mm. Click on Cutting Speed. Set the spindle speed to 800 RPM. Feed rate 200 mm per minute. Recalculate and click OK. Next, adjust the cutting parameters to a helical circular entry method. Check Start from Center in Circle and click OK. Then generate the tool path and finally click OK. Click on the specific operation. Right-click to find the tool path and find OK. For the simulation of milling the external contour, use a sequential method. This will ensure higher tool durability and a finer machined surface finish. In UG software CAM operations, each operation can only generate one tool path. Computer-aided programming can be divided into various methods. And manual programming is not a mode of computer-assisted programming. The F function of a numerical control machine tool represents the feed rate in millimeters per minute or rotations per minute. The basic control axes for a CNC milling machine are 3 axes. We can increase the processing speed and click OK after the machining is completed. Then right-click the mouse and find Post-Processing and select the corresponding post-processing file. Set the system to metric or imperial units. Then click OK and choose to overwrite the original file. The program will then be generated. After generating the program, it can be modified for optimization according to specific requirements. The operation is now complete. In today's class, we complete the second process of program design for flat and straight-walled products on the UG software platform. The selection of cutting parameters is the difficulty to this process. During the entire programming process, the contour milling machining method was used, and it's essential to leave precision machining allowances. Students can practice on their own based on the operation demonstration and roughly understand the usage and the characteristics of the above machining methods. Apply this knowledge to other similar product program designs. Thank you for listening.